Before we start our session today, I would like to talk a little bit about our assignment. It will be earned 10% for this course, and I have upload instructor sheets on the Moodle, so you can organize yourself on the Moodle. So it would be a CPB in a special case, and the case I have chosen is in the pregnancy. It's quite complicated. So, case 1. So you need to do a mini review, like a essay. Let's say total was not less than 1,000 words. So the structure could be include a introduction, like second part is annotations from related paper. It may be 3 to 5, depend or more, depend on you, but not less than 3. My idea is just you can review from any article, like case study or original research. It depends on your interest in this topic. But after you review that paper, you need to take a note, like a 150 to 250 or more per each. So you need 3 or 5. It's gonna be combined with introduction and discussion and conclusion. You're gonna get totally 1,000 words. Okay. So the third part is discussions in your own opinion and reference and conclusion. Please do it by yourself. So no need to purchase or copy from your friend and copy from the paper. If I find that you're gonna get 0. Okay. So you need to put the reference in the first part too, and the due date could be after everything done in this class. I mean about before Christmas. So all right. Any questions about our assignment? 10%. Don't miss it. Also, I would like to talk a bit about our examination, which would be performed next month, next Monday. It's gonna be about 60 questions, and the time to start and do exam. I will talk to you again in this Friday sessions. I mean, as mock test sessions that we have appointed in the Friday afternoon. Okay. Secondly, I would like to talk a little bit about that we have changed our group member for practice. So you can see here. Okay, all right. You can see here, you can see some people who changed the rotation member. So this rotation gonna combine with 332 course. The reason to change that after me and Ajahn Kinkan has talked about how many people get a vaccine and the order by that you receive the vaccine. So we need to reorganize the group again, and that you need to prepare yourself to join the group like here. So and another thing, we have another senior people who need to resit in the 332 course, and she need to resist in this course before she goes to the clinical rotation in the hospital. So she maybe help you a lot for the group too. Yes, I think because she has some experience about our lab. Okay. Any question about group rotation? All right, if not, I'm gonna start to the first session today. So we have 3 main topics today. So it's quite make you like your brain swelling. So please do it like you are living in your home, and like I just want to say, do it like your home. If you lost any part, you can interrupt me anytime. So it's quite complicated. It's always complicated in this course. So this one is the one of the challenge topic today. So it is mechanical access device. Sorry, it is a mechanical access device. All right. Yeah, it's the objective of this course. So you need to understand physiological abnormality of CPB and process of weaning of CPB, and expand any change that affect from weaning process, and how to help the people who has difficulty situation to weaning of CPB. So all right, I will talk in step by step to explain the how it's related to mechanical support device. Sorry, 1 minute, please. Okay, I'm gonna start with separation from CPB and talk a little bit about physiology, and then introduce you to know mechanical access device and classifications. Okay. Firstly, actually, mechanical access device is not only used in the in for the people who cannot separate from the CPB, but it's the most easy example to introduce you to know the mechanical access device. Okay, I'm gonna start here. Again, we need to repeat our step on the CPB. that you see we have a lot of step here, and the final step that we need to landing from the CPB is called winning the CPB. That is, we need to ensure that people who undergoing CPB is safe, like you safe and sound landing. So but anyway, the CPB is effect on the normal physiology. So if you see here, we are connect the CPB with the RA, and another side we connect to the arterial side, right? But we run the CPB as a non-positive flow. It's not physiological status at all. Secondly, some case we need to do the hypothermia, and other case we do the hemodilution. Okay, we need the heparinization. We give a heparin to maintain the blood flow. Also, the electrolyte and any endocrine has changed, and inflammatory response. And in terms of the ischemia and lipofuscin injury can be occur due to this artificial circulations and operation on this procedure. So let's imagine about the event that you need to winning the CPB. So the anesthesiologist will be start the ventilation by using the ventilator, and all the physiological alarm will be turned on and check and turn on. You need to recheck the blood gas and electrolyte lab, and the surgeon need to de-airing the heart, like you need to fill up the blood back to the heart, and they're gonna win out the air out of the heart chamber to make sure that there's no any embolic event. And sometimes we need to prepare epicardial bracings for the weaning from the CPB, because sometimes the heart remains suppressed. We have to stop the heart by using the cardiopegia, right? And sometimes it cannot get back. So you need to use some stimulation by using bracings or pacemaker to start the heart pumping again. So here is checklist for the weaning from the cardiac bypass. It seemed like the previous topic, right? So the most important thing that we gonna mention today is mechanical support, like IABP, SCDY, other SCDYs. Okay. You need to have the magic machine beside you. Okay. So any people that take a list on failure to sorry. So sorry. Any people who has a list on to failure to winning from the CPB, it may include that preoperative ventricular function is quite poor, who has poor EF, ejection fractions, poor pumping before coming to have a cardiac surgery, something like that. urgent and emergency surgery. That is quite high risk because in emergency we need to just only prepare some important equipment. So sometimes we and the urgent situation make me like much more excited and nervous. Sometimes we lost something to prepare a special machine. We we just leave it in the last thing that we think about. So sometimes we need to sometimes if the patient who has emergency situation quite high risk for failure to win. Okay, prolong. Okay, and all right. In case of emergency, the patient always has a lot of volume loading before to coming to the hospital. So volume loading is maybe disturb the cardiac functions like a high payload to the heart. I will talk about it later, how the payload affect to the cardiac output. Okay. The prolonged cardiac aortic cross-clamp. So we have long ischemic time to the heart, so the heart cannot be come back. Recover in the short period. So we need to wait and see. Sometimes just wait and see until it's good pumping. But some people it cannot come back by a minute. So you need to take more time to it, or you need to use the magic machine to help them. Okay, inadequate myocardial protections. For some cases that with the people who has some early like not good cross-clamp, not good cardioplegia, not good giving the cardioplegia period. Like if you have it time like 30 minutes, the surgeon need to extend more time. That's kind of the inadequate protection can be also make a failure to weaning from the cardiopulmonary bypass, and also incomplete surgical repair. That means an experienced surgeon can do not do all the procedure complete, so it can be make a risk for winning, right? So let's go to a little bit about the physiology of the renal return and cardiac output. So the cardiac function can drive from the two parts, a mechanical and electrical functions. A electrical function, you may know that is gonna start from the SA node, right, to the arterial and any pacemaker, and goes the track go to ventricle and make a heart pumping. Another side of the function is called mechanical functions that mainly focusing on the a flow, a contraction, and so on. So that's quite related to the volume and contraction. So this slide just show you here there are two main functions of the heart pumping. to winning of the heart, you need to balance between a mechanical and electrical functions. Both you need to control of this. For the focusing on the mechanical function, you may familiar with this diagram. That is just show you a how the volume that relate to the cardiac output. So we have a circulation like here, and the volume is come back, return to the RA, and then the ventricle gonna pumping out the blood into the aorta, right? So if you here, you can see the relation of the each chamber. Focus on the LV chambers, and it valve relate to the systolic and diastolic functions, and also volume inside the heart. Right, you may familiar with LV pressure, volume, loop like here. Focusing on the mitral valve and aortic valve open and close, and pressure and volume change inside of this chamber. And also we have the straight and unstraight volume like here. So you can see if we have another straight volume, the volume that extract from the optimized volume. So it can be make a much huge, like a larger arrow here. Input into right atrium. So that means it's increase the preload volume. So how it's related to winning? Another thing that you need to know is that we have a sarcomere, and sarcomere length inside the heart, right? So if you see the empty ventricle and full ventricle here, you can see the sarcomere length had been changed, but heart just only needs some length, like optimal length for pumping. So the green zone here, you can see the contractions that relate to the length. How to measure the length? It's not easy because you need to put it in the microscopy to see the how it changes, right? So in practical, we can measure by using the volume. So imagine that if you put the volume inside the heart too much, the length gonna stretch out, something like that. So the optimal volume gonna make a optimal sarcomere length to push the contraction out. So if it's too much, you can see the red line here, it's gonna drop down, right? Like tension on the muscle stretching, so it's gonna rise up. So it's gonna, oh, I cannot pump out anymore, no need a volume anymore, thing like that. So this is the how length depending activations relate to winning of the pump. Back to our routine technique on the pump winning. So when we winning the pump, we need to pinch the cam on the venous line, just a little bit step occlusions on the venous lines. So that means you are allow some blood back to the heart via the venous line. So reduce the drainage from the native circulation and reduce the flow support from the heart lung machine. So the patient heart's gonna have much more volume inside the heart. That means you give back the preload to the heart, right? It's gonna affect to the circumference too, as I mentioned above. So we need to optimize this kind of volume to push out the good cardiac output. If you get that too much, it's gonna be go like extend and cannot pump much. That can cause the pumping failure. If it's too much and cannot reverse or recover, it's gonna make your cannot separate from the CPB or winning gonna be fail. So it's very important in winning. You need to practice and observe and so on this kind of state. Frank Starling law is quite related to this process. Okay, to make a good cell volume, need to balance the volume back to the heart. Okay, so here is here is the diagram that show you how does it change during the winning of the CPB. So when we run the pump, there are the non-positive flow to the circulations. If we put a little bit of volume back to the heart gonna make a little bit pumping. You're gonna see the arterial wave line here. You're gonna see pulse pressure, how different pulse pressure, and the pulse pressure gonna pump in, pump out, relate to the ACG, and relate to the CVP or central venous pressure. Sometimes it can be represents the preload. It's not actually represent the preload in some time, but in this time we're gonna use that to measure how much the volume get back to the heart. So you're gonna see if we increase some preload or some volume back to the heart gonna go back to pumping again. All right. Like last session we have a video from PD. I'm not sure which minute that she talked about winning. Okay. So to separate the heart from the bypass, okay, it's not gonna focus on it cannot focus on the right and left ventricle pumping and the contraction. So you need to balance the venous return and vascular resistance and contractility. So you need to concern about this tension, and coronary perfusion gonna get back if you has optimized volume and pumping. All right. Here is the diagram show you a cause of the BP drop and increase during winning of the pump. So here is step to weaning, like if you have occurred the venous line and maintain partial bypass, and stop pump when the like is good contraction and good pumping. So you can stop pump like that. So after that, some team gonna measure the hemodynamic where they transesophageal echocardiogram to measure the EF or the heart functions. After that, if not good in stroke volume and contractility, you're gonna concern to use the drug like inotropic drug or control by giving the much more another volume. It might be from our pump or maybe from anesthesiology. Anyway, if the drug and volume cannot help, we're gonna think about a mechanical circulatory support system. All right. Here again, like talk about preload and cardiac functions after terminating of CPB. After landing, we're gonna see from the clinical size, vital size. Okay. So if it cannot recover like cardiovascular decompensations, we can use mechanical support. So here is an algorithm of failure to weaning from the CPB. So for summarize, sometimes we need to get back to the CPB again. Sometimes the heart cannot get back, right? It cannot recover. So we need to support for some periods until the heart is okay. Okay. Some case, especially for small people, the chest remains spreading. I mean, if the heart swelling, like if there are some edema to the heart gonna be larger than usual, right? So the surgeon gonna make decisions on still open the sternum or not. If it's if the reason why that remain open is that if we cause the sternum, it's gonna be compressed on that edema heart, and heart gonna easy to pumping. So we just leave the heart, the chest open to allow the heart pumping until the swelling cell came back, and we gonna cause the sternum again. But it's quite complicated and need to care about the infectious control too much, because the chest gonna remain open. This may be take time for a few days. It may be sometime just overnight, and tomorrow after the patient got the diuretic or anything else to support to reduce the heart edema, the heart gonna came back to a bubble size again. So so the team can go to make a course the chamber, code the chest chamber again, right? And as as I told you, we need to try to use the some drug before we decide to use the mechanical support. All right. Okay. Sometimes is you need to find the real cause of the pressure drop. It might be from reducing straight volume. That means the volume that come back to the heart, right? Maybe from the massive breathing, and sometimes it's related to increasing its compliance. I mean, vasculature has dilatation, so it needs more volume to hold in that kind of vasculature. So here is my relate to the sepsis or any vasodilator or anaphylactic shock, okay, or a orthopedic syndrome like nerve or any loss functions, okay, or some hormone. All right. That one is the is reducing mean arterial pressure, right? So another size is increase in right eye pressure. So here is the cause that's related to the eye pressure. So like retinal light dysfunctions, any obstruction on the upper tract, any embolism that can cause the obstructions and malfunction to pumping. I mean, if it cannot pumping in the distal part, it can be affect to another part, like initial part. I mean, if there are some, if the ventricle cannot pump out, it's gonna make a atrium rising in the volume also. And also some compartment syndrome and vena cava syndrome. That means you have some leak out to the any compartment, any part of the body. It's gonna be reduced in venous return also. So here's a diagram that shows you how to reduce the venous return and this help to the venous arterial pressure. So you can see this is the relate to reducing mean venous system pressure, like reduce volume and increase compliance. If it heal box, you need to another volume to add in the box or something like that. Okay. All right. If it's failure to weaning from the CPB, okay, it's back again. Therefore, strategy. Okay. All right. Here is the basics that relate to use the another magic device. Before to go that, any question about the first session? มีคำถามไหมครับ ยังอยู่ไหมครับ
ยังอยู่ค่ะ ยังไม่มีคำถามค่ะ
โอเคแต่ตอนบ่ายขอหน้าม้าหน่อยเนาะ อาจารย์อยากให้มีหน้าม้าหน่อย All right, we're gonna moving to the next session today. อาจารย์ล้อเล่นนะ แต่ว่าอย่างที่บอกครับถ้าเกิดเรามี guest speaker ทางที่ดีที่สุดที่เราจะ make relation กับเขาก็คือเราต้องมี participate กับเขาไหนๆเขาก็มาแล้วก็วันหนึ่งถ้าอาจารย์ส่งเราไปเขาก็จะได้จำเราได้ว่าแบบน้องพี่เคยมาอะไรเงี้ยเนาะโอเค A mechanical circulatory support device here is a special device that we using to support the patients who may have the failure to weaning from the CPB. Okay, here is the definitions of that kind of device. You may call a MCS. Okay. It is a device to increase the cardiac output in patients to make breakthrough decisions. I mean, decision to do something. If the operation is failed, you're gonna look out for some periods to make sure to support the team, to support the family before we go to. Okay, for example, you need to terminate the patient. You need to put the patient in some state that until the family accepts about that kind of the progress. Okay, this is the decisions or need to decisions on the further surgery. That means the previous operation is not enough to help the patient. So you need to sometimes to think about it and wait and see and do it back again. So this is a breakthrough decision, breakthrough recovery. As I told you, some people who not recover by the minute or by an hour support. If we just have another machine to help them, it's gonna be bad. But it may take time, like a day or month, so complicated to expand, but it depends. Breakthrough candidate for the transplantations. This is quite important also because the native heart is quite weak and cannot pumping or function at all. So, but it's quite a long queue for transplantation. So put them on the mechanical support until receive the new heart. It's gonna be short. And the goal of these kinds of machine is that to improve the perfusions and functions of the organ immediately after put on these machines. So in the long term, it's going to improve their quality of life and patient's prognosis. That is important thing. Okay. And also, as I told you, use as a destination therapy in the patients who are not who want to come back, right? So it's quite sad story, but that's true. Okay, it might be hope and hope. Okay. It's going to be classified into three group, but some textbook gonna separate just into short term and long term. So here is some example about the mechanical support like short term that we gonna talk today is ABP, and then next Wednesday gonna be Ecmo, and midterm and long term. We have a guest speaker from the Ram Antibody Hospital who has some experience about that. So it's gonna be called WAT and bypass support. So for long term, that is not shown in this slide. It's maybe referred to the artificial heart, but it's quite rare in Thailand. So I put the topic just only Ecmo and WAT and IABP that might be useful for you. Artificial heart for Thailand is a long future. So if you're interested in that, you need to go to the further reading, or if you interested in research on that, you need to go further continue your educations in PhD or something like that. Okay, here is another example to divide the MCS into the short term and long term. So you can see here the AVP duration is within the day count, like maybe a few days, maybe in almost a week. But for the Ecmo, is more take time longer as a week. And another choice like WAT here. It's just some system gonna take time for a week and day. Okay. Here is a prolong. It's prolong. It's a commercial name sometimes. Tortec is commercial name. Novacor is commercial name. So you're gonna see much more detail from Ajahn Sumeti session next. All right. So to make it easy, it's gonna be said that you can see the comparisons between IABP, the WAT, which is in this B and C, and the Ecmo. So you can see here is the balloon inside the aorta, right? Descending aorta, right? So we insert the catheter into the groin, femoral artery, and put the balloon to here to make an infection and defections on this. How that is held is gonna be further lecture. Impella and tender heart is the WAT, but it's different system. Ajahn Sumeti will be talk about it again, but how is different from the Ecmo? The Ecmo seem like a prolonged CPB. Ecmo contain with pump and also oxygenator, but the WAT there are only pump. No need for oxygenator to support the lung. Okay. In terms of intra-aortic balloon pump that we're gonna talk today, just for introduction. So we put the balloon inside the aorta here. You see there are infections and defections like here, the effect on that gonna surely is gonna affect on the arterial waveform because it's directly perform its functions on the aorta, right? So in each step, gonna make physiologics and affections to the hemodynamic also. We're gonna discuss later. Okay. For the Ecmo that you see, there are a oxygenator and pump here. It seems like a CPB that I said, but it's cut out a reservoir. It's cut out some complex part because now we need to much more longer period to run this kind of circulation. So to cut out the complicated device, it's gonna be less more effect on this on the artificial circulation. So here is the Ecmo. We're gonna talk later in the next next chapter, next section. So here is an example for the assistive device, and you can see here is the pump inside the shade and another controller in the external of the body, and power bank or power source here gonna connect with this kind of the machine. It's quite complicated. And also this one is the another setting. So you're gonna see this from a transformative section. Okay. The most indication that's used for to make decisions on the mechanical circuits, of course, is that cardiogenic shock. So here is the algorithm to use the to support the cardiogenic shock. Start from the easier process that using the IABP here, or with the inotropic, is if it cannot come back, and consider to using the WAT system, something like that. Okay. For summary, that talk we have talked about the winning from the pump, the winning effect to the payload and stroke volume. You need to concern Frank-Starling law, Frank-Starling mechanism that mentions about sarcomere length, payload and sarcomere length, quite important. You need to balance payload. You give back a payload and observe the cardiac output. If not optimized, the sarcomere length and can cause the winning failure and can cause the ventricular failure. So we need to consider to back to the heart, remain open sternum, any drug support, or finally we need to mechanical support. Yes, that is all for the mechanical support as an introduction. Any questions about this topic?มีคำถามไหมครับ
ไม่มีค่ะ
Okay. If not, I'm gonna break for 15 minutes. You're gonna come back on okay, we're gonna come back on 10:50. So Okay, to go on to the next sessions. 10:50. Okay, all right. See
อา
you.
จารย์คะหนูขอสอบถามได้ไหมคะ
Okay, all right. มา
แต่คือไม่ได้เกี่ยวกับเรื่องเลคเชอร์ที่เรียนนะคะ อาจารย์
Okay.
โอเคค่ะ อาจารย์คะคือหนูอยากทราบเหตุผลว่าทำไมอาจารย์ถึงเปลี่ยนกลุ่มแลบหรอคะเพราะว่าเหมือนหนูรวมถึงตัวหนูด้วย แล้วก็มีเพื่อนๆหลายคนนะคะคือทำการวางแผนไว้แล้วอะค่ะ อาจารย์
อันดับแรกเลยมีรุ่นพี่คนหนึ่งที่เขาแบบต้องมารีซิปกับเราอ่ะเขาต้องมา attend lab อันดับสองก็คืออยากให้ make sure เรื่องวัคซีนคือจัดกรุ๊ปตามวัคซีนออเดอร์ครับคือที่อัปเดตล่าสุดว่าเราแบบได้วัคซีนก่อนหลังอะไรเงี้ยครับ คืออยากให้มาแล้วมันเซฟแบบไม่อยากให้มาแล้วมันแบบเขาต้องมากังวลกันอะไรอย่างเงี้ยครับ
อาจารย์ค่ะแต่ว่าแบบอย่างหนูอย่างเงี้ยคือได้มีการวางแผนไว้แล้วค่ะคือหนูจะต้องแบบไปต่างจังหวัดเพื่อที่จะไปดำเนินเรื่องของเอกสารอย่างเงี้ยค่ะ อาจารย์ใช่ค่ะ แล้วก็มีเพื่อนแบบเท่าที่สอบถามเพื่อนๆคนอื่นๆก็คือมีบางส่วนก็คือได้วางแผนกันไว้แล้วอะค่ะ อาจารย์
เอาไงดี เดี๋ยวคุยกันอีกทีได้ไหมหลังจบก็ได้
ได้ค่ะอาจารย์
มีกี่คนนะครับในนูรุนลองรวมชื่อมาให้ดูหน่อยน่าจะมีบางคนที่เข้าใจว่าแบบเปลี่ยนจากรอบแรกเป็นรอบสองใช่ไหมที่พูดถึงอ่ะ
ใช่ค่ะใช่ค่ะ
อืมโอเคไหนลองรวบรวมมาให้หน่อยครับ
ได้ค่ะอาจารย์
ครับผมโอเคเจอกัน10:15 alright โอเคเอางี้กลับมาหมดยังโอเคนักเรียนกลับมากันหรือยังครับ
กลับมาแล้วค่ะ
โอเคเรื่องจัดกรุ๊ปเอางี้ อยู่กันครบนะเอาใหม่เดี๋ยวให้เราจัดกันมาเลยก็ได้เป็น4กรุ๊ปนะครับกรุ๊ปละ5คนนะครับแต่ว่าให้ใส่ชื่อพี่จ๋าไว้รอบแรกเพราะว่าพี่จ๋าต้องไปฝึกงานต่อจาก practice ตรงนี้เพราะฉะนั้นให้พี่จ๋าอยู่ในกรุ๊ปหนึ่งแล้วก็กรุ๊ปหนึ่งอะครับกรุ๊ปหนึ่งก็จะเหลืออยู่4คนให้เราเพิ่มมาเนาะก็ลองไปคุยกันแล้วก็จัดชื่อแล้วก็ให้นูรูนส่งมาให้อาจารย์อีกทีนะครับโอเคไหม
อาจารย์ค่ะ
ครับ
ถ้าสมมติว่าถ้าเป็นกลุ่มเดิมแต่ว่าเอาพี่มาอยู่กลุ่มหนึ่งได้หรือเปล่าคะ
พี่มาอยู่กลุ่มหนึ่งมันจะเป็น6คนนะใช่ไหม
แป๊บนึงนะคะ
ได้ไหมขอโทษดิได้ไหมครับเดี๋ยวเราลองไปประชุมกันแล้วลองคุยกันดูแล้วก็จัดกลุ่มมาแล้วกันนะครับเอากลุ่มละ5คนเนาะแล้วก็ให้พี่จ๋าเขาอยู่กลุ่มแรกเดี๋ยวเขาจะได้ไปฝึกงานกันนะครับส่วนอย่างอื่นให้ดูกันเอาเองเนาะแล้วก็อาจารย์อยากให้ไปอัปเดตคนที่ได้วัคซีนเท่าไหร่อะไรยังไงแล้วนะครับจะได้เฝ้าระวังกันถูกนะครับแล้วก็เนื่องด้วยเราจัดแบบนี้เนาะตอนแรกเนี่ยจะเอา กลุ่มที่เสี่ยงมากที่สุดเนี่ยไว้ท้ายๆเพราะว่าเพื่อนที่มาก่อนเนี่ยก็จะได้ไม่ต้องเสี่ยงหมายถึงว่าถ้ามีคนใดคนหนึ่งในกลุ่มแรกๆติดโควิดหรือมีปัญหาเกี่ยวกับโควิดให้เป็นหมายว่าเราจะถูกยกเลิกทั้งคลาสจนกว่าสถานการณ์จะดีขึ้นแล้วเราค่อยกลับมาใหม่เข้าใจไหมครับเพราะฉะนั้นในระหว่างที่ทุกคนรอที่จะมานะครับรักษาเนื้อรักษาตัวให้ดีๆจนกว่าเราจะได้มาเจอกันนะครับอาจารย์อยากเจอทุกคนอาจารย์อยากพาทุกคน hand on เพราะว่าวิชาอาจารย์วิชาผมเนี่ยแฮปปี้ที่สุดก็คือการ hand on จะทำให้เรารู้เรื่องทุกอย่างดีมากกว่าเดิมนะครับโอเคฝากไปจัดกลุ่มมาแล้วก็ฝากเรื่อง stay safe เนาะ
ได้ค่ะอาจารย์
โอเคดูแลตัวเองนะลูกๆผมก็ต้องดูแลตัวเองด้วยนะครับ All right, we're gonna start to the next session. I would like to talk about intra-aortic balloon pump. Here is the topic number 7 and the second topic for today. Okay, all right, for today, I would like to introduce what is the IABP and then talk about the system, the machines, and the catheter that we use for IABP system. Next, gonna talk about physiology a little bit and house insertions. And the next is the management and the winning and a complication of this kind of system. So firstly, what is the IABP? IABP is the infrared and deflated balloon that we put in the aorta. It is a counterprostate that main is gonna inflate the pump push out the volume of the heart. It is the short term or temporary machine to support the patients. So it can be support hemodynamic or in the coronary and systemic to increase the coronary blood flow. And also unload the ventricular load during systole. Sorry for my typo. And that's kind of effect gonna displace of the blood mass by the volume that expand inside the balloon. Okay, it's used since early 1960s and still used for the first line. So here is the indications of the using IABP. Some textbook using the term IABP and total prostate machines or something like that. So to increase the coronary perfusions, it may be useful for the patient who has angina. Before I go to the PCI and also who has MI or myocardial infarctions. Also, for some patients who has suffered on the afterload So it might be short. And also the prophylactic indication does mean to protect the progress on the worst event. You can use the IABP to support the patient before you go to further procedure. Okay. But contraindications. So we have we need to put the balloon inside our aorta. So any kind of disease that relate to the aortic functions, I mean the aorta and aortic valve, gonna be a contraindication. So imagine if we have aortic regurgitations. That means if you inflate the balloon, it's gonna make blood leak back to the LV, right? So it may be cause the LV much more distant. So we need to avoid a patient who has the AR. Also in aneurysms and dissections, because of the aneurysm and dissections is directly effect on the aortic anatomy. So if we put the balloon inside of that, it's gonna be this type of the aorta flow or arterial flow. All right. Also, because some case, most of the IABP we put the catheter where the groin or where the femoral artery. So if there are some problem in this site, it may be because the injury and much more serious complications. So we need to avoid some patient who has that disease. So we need to see what is the machines of this kind of procedure. So IABP system. It consists of two main parts, which is the catheter and machine. So you can see here, it is a catheter. In the tip of catheter, there are a long balloon like a sachet here. And you see, this is the console or machine, which is you can see the control panel here and display, and also the big part of machine in the cart here. So let's see the more detail in the next slide. Okay, here is the picture that show you that we have put the catheter into the femoral artery, and this kind of catheter gonna go to inside the aorta. At the tip of that, you have a big sausage inside your aorta, like this. Okay. For here that I show you from the real one and to the cartoon picture here, you can see anatomy of the system. So here is the balloon. That you see the balloon is gonna be different site depend on the indication. So you can see it's very size, and also inside a balloon there are two lumen. You can see blood lumen here, and also a gas lumen. We use a lot. We use helium to support the balloon inflate and deflate, because helium is an inert and it's gonna be reduce the list of the embolic event. So the helium, if there are some leak out from the to the blood system, to circulatory system, it's gonna be easy to disappear. So the helium is a choice for the gas support in this system. In the catheter, you see there are two parts. The part that inside the vessels and the part that outside the vessel or outside the body. So outside the body, you're gonna see the plastic cup that's gonna fit the position to the vessels and balloon. In this this part gonna separate into two parts. One is supported by a gas helium. So here, look at this inside the cross sections. The helium gonna contain in this side, right? So it's gonna connect with a helium tank and connect with the pressure. No, it's gonna connect with the measurement system like here. And also another part, like a butt lumen inside of here. We use this lumen to measure the arterial pressure. So it's gonna connect with the arterial pressure transducers with the extension line. These two parts gonna connect to the IMEP machine and console here. All right. This is an overview of the machine. Okay. For more detail about the machine and catheter, you can see each part of the catheter. Okay. So here is the balloon rack, and here is the like a two port. One for measure arterial pressure, and one for connect to the gas. So you're gonna see this kind of part gonna connect to the gas here. So you can see the helium tank here. It's gonna provide gas to the tube and go to here like a regulator here and connect with the balloon. Okay. And these pictures also show you a power cord and on-off switch here. And also it can connect to the ECG cable and also the pressure transducer can connect to here. So let's say this component gonna show you the gas support, EKG connection, and also the pressure connection. All right. For the control panel, you can see there are a lot of waveforms. So you can see the EKG trace show you here. It's maybe lead 1, lead 2, or lead 3, depend on your shirt. But most people choose lead 2 because it's quite easy to see the waveform. And also arterial pressure, gonna show you here, and the balloon function pressure waveform gonna show you here. So for today, we're gonna mention a lot in the ECG and also the arterial pressure. Below this, you're gonna see the control panel. Like you can choose the mode like auto, pilot, like semi-auto or manual, and you can start from here or standby. Okay, And you can adjust the timing to trigger the infections. Another in left hand side, you can see the trigger side is maybe a trigger from EKG, pressing, pressure, pacemaker, so on. All right. And frequency, the mean ratio, how many beats that you need to inflate, how many beats that you need to deflate. Okay, relate to EKG and arterial waveform. Okay, and this one is gonna show you the manual feel of balloon bottom. So if you had a chance, we gonna hand on this kind of machine the next term maybe. Okay. All right. In next sessions, I would like to talk about how to shoot the balloon size. In the market, there are some different, maybe 20 cc to 60 cc. It depends on the patient side because the aorta size and the patient height gonna relate to how long of the catheter that we shoot, and also the volume of balloon. So you can see there are some there are any there are a chart to shoot the balloon size for the patient. Okay, you can see maybe we cannot put the intra-aortic balloon pump in for support a neonate and small children. So if that kind of patient has suffered on a cardiogenic shock, we're gonna consider to use another device support. Okay. I would like to move on to a little bit about physiology. So you can see here there are arterial waveform and also the EKG, right? So you can see the component of arterial waveform. You can see is pressure during systolic and diastolic. Between that, we have a dichotic knot that represent the aortic wall cursor, and this is the beginning of the relaxations. At that time, the coronary perfusion gonna occur, right? To clear more, you can see the coronary perfusion can be occurred due to the closings of the aortic valve. So we're gonna use this principle for measuring the pressure during the performing IABP. Okay, all right, sorry. So here is the example of the IABP waveform. You can see the waveform from the arterial pressure going to be changed after we have inflate the balloon. So the patient gonna be rising up after we inflate balloon, right? So it's maybe above the native pressure, let's say the normal pressure here. And after that, is certain defects. The pressure gonna dip down. Okay, keep. We gonna talk about detail later. Okay. Okay, as I how to do like. Okay, we have inflations during the diastole. So let's say it's the diastolic augmentation gonna be occur. So you can see here the pressure rising up, right? So at that time, coronary perfusion and flow gonna increase. So the myocardial gonna get much more oxygen, and the coronary circulation can occur. So it can be said that it's during infections, the coronary support, the coronary perfusion gonna be increased, right? Also, in another side, we have a side in above here and another side in the below. The perfusion to the distal organ like a kidney also support, right? And also another blood gonna go to the brain in the above here. Okay, does it make sense? Okay, after that we're gonna deflate. The deflate gonna occur after systolic during isovolumic contractions. After contractions, it's deflate quickly. So at the time it's gonna make like empty evacuations of the blood mass inside of the aorta. So the LV no need to force much blood out from its chamber. So it's gonna help in the relaxations, in the contractions, and it's gonna be used less the energy. So the oxygen demand is gonna like reduce also. And also that's kind of empty. That kind of empty. It can be said that it's reduced after load. Okay. And the next is gonna help in improve the stroke volume and cardiac output. Okay. For the timing again, to repeat that slide. Okay. This one is the proper IABP timing. You can see inflection gonna occur at the diacritic node. It's gonna be appear V-shape of the waveform. So you can see the V-shape here, analyzing the I think of the diacritic augmentation here. Okay. Sorry. Sorry. Okay. That is the infection. For the infections, it's gonna be occur after that, and result is reduced in the acidic and reduced in another phase that I have talked in the previous slides. So here is the effect of the intra-aortic balloon pump. All right. Balloon infection gonna increase the coronary perfusion and improve myocardial performance, right? And exercise is balloon displacement. That means a sudden deflating gonna improve the systemic perfusion also. So it gonna be help in the oxygen demand and or shear state of the LV, and you're gonna improve the myocardial performance also. And also this kind of sudden deflation is gonna reduce the afterload for the heart, so the heart gonna easy to pump out, right? And so if we have afterload reducing, it's also improve the systemic perfusion also. It's kind of like a circle here. Here is the effect of the AVP. Okay. So the next sessions, give me more 1 minute to check the link. Okay. All right. Okay. Insertion technique. It's quite complicated to demonstrate online. However, I have a YouTube video that you can see from the video by yourself. Okay. Insertion technique. Not only femoral artery, we can also insert that into the let's say a brachial artery and axillary artery. Just put the balloon into the descending aorta. But however, you need to keep the balloon below the subclavian artery here, and also above the renal artery, because it can be obstruct both vessels. If you obstruct the subclavian, you're gonna make a complicate on the limb perfusion to patient arms. And if you obstruct into the renal artery, it maybe disturb the blood flow to the kidney. So sometimes we need to recheck by X-ray or a ultrasound. And the technique that gonna approach to insert that kind of catheter is called cylinder technique. Okay. So here is the positions that I said. One or some reference says 1 centimeter. Some reference says 3 centimeters. It depends on your setting. So here is the X-ray picture show you the marker on the balloon, and you see the balloon tip is here. Okay. Here is this technique that I have mentioned. It's called cylinder technique. Okay. So this one is gonna call sheet insertions. That means it can be put the sheets into this process, but some process no need a sheet. Some technique no need a sheet, but I didn't talk today. I give this just only to make you to understand the idea to make insertions by using the modified Schillinger technique, Schillinger technique. So it's gonna start with using the needle puncture to the vessel here, and the physician will be put a guide wire through this needle lumen, a little bit cut down, take the needle out, so you can see the guide wire remain inside the vessel. Then you have a introducer dilator and the sheet inside of dilator here, and put it together to the over the guide wire, and put it into the vessel. The reason that we use a guide wire is that it's a guide wire by the name is the guide. So a guide wire can be reduce the risk of the vessel trauma. If we put the sheet, introduction sheet and dilator directly to the vessel, to this process, it's gonna the tip of the dilator may be injured to the vessel wall here, right? So the guide wire gonna reduce the risk of this injury. And then if the introduction sheet and introducer dilator in the place, you can change the guide wire to smaller guide wire, because smaller guide wire gonna support to the balloon catheter. So now after we have set the positions for the guide wire, you can now put the IABP catheter through the sheath and guide wire. Okay, and after that you need to lock to fix the position for the IABP. Okay. So then you have to check to deflate the and prepare the a arterial pressure system, and also the pressure system. And then another side, you're gonna connect to the machine like this. You may have some extensions, catheter. Okay, so I have an example of this, but I'm not sure this is question more. No, sorry, wait a minute. Okay, I have two video. The first one is how to insert the IABP. Second one is the nurse role at the bedside to the procedure. However, sometimes it's not a nurse, it may be you you're gonna perform with precision to prepare the IABP, right? Okay, yeah, you can take over that's function. Here is the catheter tree. So can you see the sheet with gonna insert to the patient itself. And I take the needle out and keep the sheet remain into the vessel. You're gonna see some blood leak out. And that kind of oh, it's too fast. Right. So you can see he input the white into that sheet. And put the get a later. And delete until we happy and put a sheet inside of that. Sheet is like a tube. Okay. Okay. So here is the balloon insertion. So I would like to show you another video that that's a simulator on the balloon insertions. So here is the patients, and there is a nurse. Okay. And the patient need to insert balloon. So here is the preparations for the IABP insertions for here. You can see a mass, you can see the saline, you can see the transducer, also the catheter here. Okay, you can see brown. Okay. Anyway, this is all will be performed in the aseptic technique. Keep as sterile as much as we can. So here is the nurse performing to prepare the machine. Okay. And attach the EKG into the patient's skin and connect to to the machine and prepare the transducer, pressure transducer, because we use that to connect with the machine and also the catheter. Right. Here is the saline bag to support the arterial pressure measurement. The display shows the EKG line in the green and also not yet measured, but EKG in the green. The red line gonna be arterial, and the blue line gonna be a balloon waveform. Okay. So physician's coming. Okay. Recheck the patient condition. Okay. Mark. He gonna mark the the insertion site, and then he gonna wash his hand and gonna wear a sterile suit. Okay, we need to practice to perform a aseptic and sterile technique too, like this. As I has mentioned about this, so you can see there are some methods to open. There are a method to open the pack, okay, and keep it in sterile. So here is the sterilizer. You need someone to help. And you need to learn how to wear the clothing like it. Unfortunately, we caught in the COVID, right? So some lab that we should do, we can't do. We can't do. So if you have a chance to do that, you're gonna see more clear in the sterile technique. Okay. But this one is good example to for you. You can see the nurse has some device, right? So she need to avoid to touch any anything in the sterile field. Also, this one gonna be ultrasound to help insertion to okay. They're gonna cover by a plastic to keep it in sterile. So the sterile part gonna only see in the on the table, right? Here is the catheter and dilator and the sheet. So. And here is the tubing to measure the pressure. All right. Just for some idea, you can see it by yourself. Okay. So you can see that they sent any device by using aseptic technique. keep the assertive technique. Connect to the machine. Okay. Perform the insertion by modified cylinder. Okay. All right. You okay? I hope you have some time to review on this video again. Okay. Yeah, is open after that. Okay. Okay, we gonna move on to the next slide. After we insert the balloon and we gonna start the machine to support the heart pumping. Okay, how to manage it is, and here is the basic management of the patient who using the IABP. So you can see in this table, firstly, you need to recheck the position of balloon, maybe an hour. Okay, insertion site, and any bleeding or any signs of infection or not. A pulse to limb perfusion, because we have insert a catheter where the femoral artery, right? So it's gonna disturb a lower part perfusions. So to observe this kind of complication, you need to detect the limb ischemia event. Okay. And because sometimes we just only use a little bit of heparin, it's not enough to protect the blood clot inside the arterial line pressure catheter. So we need to flush the heparins for some time. Okay. And we need to check the urine output that I said early. The balloon might be obstruct the renal artery and can cause the urine reduce. So to make sure, you need to recheck about that. And then check the pump blood or any leakage from the balloon. Okay. Trigger. I said above, we have the trigger to send the signals to the machine when the appropriate infractions. So in terms of trigger, it's gonna be used. It might be used the signal from the surface ECG. Immediately after our wave, balloon can be triggered. And also we can use the arterial waveform trigger on the diastatic knot. Okay, does that make sense? Or some patients who has irregular rhythm, it might be synchronized with the pacemaker or the facing rhythm. Okay. Or in some patients, if there are no cardiac output, that means quite severe, and also still alias, no EKG, or the EKG is quite poor. Internal synchronization mode, that means patient you need to trigger by your adjust on the machine by yourself. So it can be applied to the trigger system. The next thing that is the ratio. So it depends on the hemodynamic and start with 1:1. So what is the 1:1? That means 1:1. It refer the IABP support in every beat of the heart pumping. If you see that it's no normal arterial waveform, right? So you see every beat has the assist by the balloon. But 1, 2, 2, that means the balloon will be augmented in every 2 beat. One assist, another one normal, one assist and normal, like this. So it can be said if you need to 100% support or much more support by ABP, you're gonna be increase the frequency like 1:1. But if you want to win the IABP or reduce the assistance from the IABP, IABP, the ratio gonna be really like 1:1, 1:2, or 1:3, something like that. From 1:3, you can see 1 beat assist, 2 beat skip normal, like normal, and back to assist again, like this. Okay. However, if we adjust the timing like in appropriate time, so it can be caused firstly early interventions. That means it's quite augment early. The waveform gonna be, see here, that you see dichotic knot here. You adjust like you set your setting is like here. And infrared balloon, the balloon gonna be augment here. You can see there it's cannot help much like to this. So this is the consequence of that. Okay. For the late infractions, that means your infrared at the aortic valve closes. Okay, and the augmentation waveform gonna quite equal to the normal, like here. So here is the effect of that. You gonna not help much the coronary perfusions. Okay. Another thing is that you inflate in light time, but different in the wrong time. The early diffractions also described. Okay, so here is the assist and unassist is quite equal. So here is the effect of that. Okay. And also here is the late impressions of the coronary of the IABP. So you can see this is the assist, balloon waveform gonna quite higher than the normal, so it's cannot heal at all. So here is the consequence of that also. Okay. If there are timing error, you just only adjust the timing bar in the control panel. So it's gonna be help the patient to improve the IABP. outcome. Okay. So after you're happy with the hemodynamic and patient gonna come back to recover. Okay. You're gonna say it's time to winning. How to winning. All right. Firstly, need to assess the hemodynamic. This is the one recommend to use that. Cardiac index around 2.2 to 2.5 and can maintain arterial pressure, mean arterial pressure, and stable in the vital signs. Okay, winning can be considered after that. So imagine that we have assist in every beat, right? You can reduce the assist standard by 1 to 2 and 1 to 3, or some machine can be 1 to 4. Okay. So that means you decrease support from the IABP. If we stay for the 1 to 3 as half to 1 hour, it's gonna be safe to leave the catheter out. Okay, to turn off the IABP and withdraw the catheter out of the patient. Right. Here is the process: weaning and withdraw the balloon catheter and sheath. But after that, imagine that you have accessed the vessel, right? So after that, we need to repair the vessel sometime, or sometimes we just compress or pressure on the site for a half to 1 hour. It's gonna make a insertion site to healing the vessels and there are no bleeding in that site. But you need to observe that, okay, after IABP. All right, that's it all for the setting, weaning, and management. Just overview because there are more detail, but I think if it's too much, it's gonna be make you much more confused, right? So we're gonna move to the next. Is complications. Okay, the complication can be easy to classify as the vascular related and IABP related, matching or patient related like this. So from this review article, it says the one of good review. Show you here the vascular related complications. It may be ischemic event from the obstructions of the flow, right? And it is directly insert the catheter to the vessels. A arterial injuries may be occur. May cause the dissections, maybe cause the so on. Did you know the hematoma? Hematoma like some blood leak into the inside their under the skin, and you can see the your skin going turn to like more darker, something like that. So hematoma is the one of indications that used to investigate patient complication after of after we draw the catheter. Cardiac tamponade is maybe caused from the guidewire trauma to the cardiac, to the heart. Okay. Thrombosis, because we have support with the artificial device, so the device can cause the clot surround the catheter. So if you allow that clot flood with the flow to the brain or to the any organ, the thrombosis device is quite serious one. And accidental femoral vein cannulations. So sometimes imagine that the patient in the unstable condition, it's not easy to measure the pulse by using your finger. Sometimes. And the oxygenation for some patient is quite not good. So the vein and arterial blood gonna similar, might be same. It's not less enough. I mean, the arterial blood gonna come to more darker than usual. So the physician need to make sure that the insertion site not in the wrong vessel. So from the previous video, they use the ultrasound to recheck the vessels. That's a good recommendation. Another thing, if you didn't have any ultrasound, you may be checked from the arterial blood gas. So the blood gas in the arterial side is gonna be higher than the venous side, right? Okay, but in the some patient who has a good, like still good pressure, like still good blood pressure, even that is quite reduced from the normal. Once that the physician put the needle into the vessels, you're gonna see the blood gonna automatically flow out from the needle, like I showed in the previous video, in the first video. Okay, that is the vascular conditions that make a complication, right? And another side that you see here from this kind of table is that IABP related. Okay, a balloon can be larger, so you need to check your package, you need to check your satellite and good storage for your device. Sometimes in Thailand, you need to avoid to use to put your device outside the air conditioned room. So the temperature maybe make your device go in trouble. Also, it can be entrapment to the any vessel, and infections and safety is gonna be concerned. Okay. Balloon entrapment gonna make like a left subclavian obstruct or a renal artery obstruct, or so. You need to recheck the arms pulse, or sometimes you need to check urine output during on ABP. Okay, and recheck the balloon positions always. Okay, that is all. For summarize today, we have a counter-pulsatile machine called IABP. IABP can be held in coronary blood flow to increase the coronary blood flow, and from that, it's gonna be also increase the cardiac output and decrease the afterload. The site that we assess mostly for the FA or femoral artery place positions would be below the left subclavian about 2 or 3 centimeter, and above the renal artery for maybe the same number, 2 or 3 centimeter. That's to make sure there are no obstruct on that both vessel. Both brands, okay, and the trigger gonna be on the EKG or arterial pressure. Here is the additional YouTube video. Again, you can do it by yourself. So this is the top up that we are taught today. Okay, if you have any question, you can ask me later about that video. Okay, that's it all for today. Any question, ครับ
ยังไม่มีเลยค่ะ
ยังไม่มีนะครับ So I'm gonna leave you by early. You have 1 hour and a half to relax, and I also give you a handout in the live chat, and also you can download from the Moodle. That you see there are a lot of content today in the afternoon. So you need to take a break, have lunch, and you can take a nap to refresh your brain before the afternoon session. Okay? So if you have no question, see you in the afternoon session. All right. Bye bye.
ขอบคุณค่ะอาจารย์
ขอบคุณค่ะอาจารย์ ขอบคุณค่ะ